All right. So again, let's go into recursion, all right? I've already posted this PowerPoint online for you guys to use, okay? So let's talk recursion. Here we go. Slideshow. Okay. All right. I guess I'm just going to do it this way. All right. So tell me if you guys can see this okay. All right. And boom. Okay, can you guys see all right? Okay, so here we go. Okay, this is recursion, all right? Okay, what is it to curse? Okay, you cursed. Damn. I recurse again. Damn. That is recursion. Thank you. Thank you. Thank you. No one, only Dylan, and a slight chuckle from Logan. All right. Thank you for the applause. Thank you. Thank you. Some late applause. You don't get bonus points. And a disapproving shake of the head from Gary Wu. Now I know class has begun. All right. So, okay. That being said, let's actually get into what recursion is. Oh, I forgot I haven't done this in a while. All right. Okay. Okay, so I was kidding already. Okay, so all right, let's get started. So classic problem, factorial, okay? In algebra, factorial. I give you this problem, okay? Let's say I give you the problem 6 factorial, okay? 6 times 5 times 4 times 3 times 2 times 1. Are you guys familiar with what factorial is? Okay, it's basic algebra 1, okay? Factorial, all right? The exclamation point here, in this case in algebra, is representative of the factorial, whereas it's the negator operator in other programming languages, okay? But basically it just means to go 6 times 5 times 4 times 3 times 2 times 1. What's another way to write 6 factorial?
6 times 5 factorial.
6 times 5 factorial. What's another way to write 6 times 5 factorial?
6 times 4.
5 times 4 factorial, etc., okay? Until we get to something that we call the base case, okay? So let's take a look at this for loop, all right? So we have 6 factorial, which is 6 times 5 times 4 times 3 times 2 to 1, or 6 times 5 times 4 times 3 times 1, okay? So if we do in a for loop, okay, what we do is we say for int answer equals 1, okay? For int j equals 1, j is less than or equal to 6j plus plus, answer equals answer times j. So if I were to actually ask you guys how to do a factorial equation at this level, everyone should get this right. Everyone should get 100% on a standard for loop of doing factorials, okay? Now, recursion. Take a look at this, however, using recursion. Public int factorial int n, okay? If n equals 1, we're going to return 1. Else, return n times factorial n minus 1, okay? All right, so basically what is happening is this. Well, first of all, what do you notice about this method? What is this method doing?
It's calling itself.
It's calling on itself n times factorial n minus 1. What's the name of this method? Factorial. So what is happening is n6 times, what's 6 minus 1? We call on this method again, okay, 5, etc. The key thing, though, is this, okay? That's the key thing, all right? So, oops. All right, so let's take a look, the goods, okay? So, public, the base case, okay? In it, what controls a for loop? What controls it? Anybody but Dylan. Logan, what allows me to start or stop a for loop?
The value of j and the conditions.
Exactly, the conditions, right? The conditional statement, correct? Okay. However, in a factorial method or in a recursive method, we have something that we call a base case. Now the base case can be multiple things, okay? But it's basically what we would call the terminating statement, okay? And the terminating statement is basically your return where you're not calling upon the method anymore. So in this case, public int factorial int n, if n equals 1, God, I wish, this is one of those, this is one of these lessons where I wish I had a whiteboard. Because if I had a whiteboard, it would be so much easier to go over, okay? I will do my best with the annotations, but I can tell you already they're gonna be shite, okay? So, now, okay, if n equals 1, you're gonna return 1. Now, else, return n times factorial, okay? Now, what's actually happening, okay, in a recursive method is it wants to return something. It does, but what's happening is it wants to return this n times, okay? It wants to return this n times. However, because you have thus called on the factorial, okay, but because you have called on this, it runs it again. So what is being stored? N and the process, which is multiplication in this case, okay? So if we break it down, okay, let's take a look at this method here, okay? Next, okay, let's say we have int n equals 1, return 25. Else, return n plus boohis n minus 1. Let's say that we had 5, okay? So the first thing that's gonna happen, okay, int n, so 5 gets stored, okay, on the first call, 5 gets stored, okay? So 5 goes in 5 plus, so what gets stored? 5 plus, okay? So I'm gonna, where's my, here we go. So technically what I'm looking at, even though I have it here, okay? Actually, you know what? I don't need to annotate, let me clear this out. So technically what's getting stored is this, okay? 5 plus, all right? Then I run it with 4. Then 4 plus gets stored. Then 3 plus. Then 2 plus. And let's take a look. We finally get to 1. Finally get to 1. Okay. Now in this instance, we return 25. We return 25. Okay. You don't always have to return 1. I can return whatever number, but basically don't look at it as a return. 5 plus 4 plus, these sections of the equation have been stored. The computer wants to spit them out, okay, in this post recursion. It wants to spit it out, but for right now, it's storing them. So finally you get to a return, finally you get to a return where it's not calling on boohis anymore. It's not calling on that. Okay, it does 25. So basically what has just happened is it has just finished the equation. So what you do is what we call LIFO. Last in, first out. What was the last number that was stored? 25. What was then stored? Plus 2. What was then stored? Plus 3. What was then stored? Plus 4. What was then stored? Plus 5. So 25 plus 2 plus 3 plus 4 plus 5 equals 39. Okay. In the return, if I were to make this 15, it would be 15. You work your way out. Remember that term LIFO, last in, first out, for post recursion. Okay. Now, okay, let me see. Do I have another example here that I have you guys do? Okay, so let's take a look at this one. So adder, okay? Henry, what is the terminating statement or the base case?
I'm sorry, you cut out there. Could you repeat that?
Okay, what in this here, what is the base case? What is the terminating statement?
Wouldn't it just be like the return statement, or?
Nope. What's the condition? Eubin.
N is negative.
When n is equal to 0, less than or equal to 0. That is the base case. That is the terminating statement. Okay. What is the process? Will?
Is it the return n plus adder n minus 2?
No. What's your name? Sorry, Thanos.
Is it when it's greater than 0?
No. The process. What are we doing with all of this? Uma.
I was gonna say, would it just be returning 30?
No. Dylan?
We're adding.
We're adding. That's the process. We are adding these numbers together. Okay. So, first of all, let's take a look. I don't want to know what the answer is. I don't want to know what the answer is yet. Okay. First, on your show of hands, okay, on one hand, how many times is this going to run? Anybody? Okay. Henry, I don't see your hand. Uma. Okay, let's take a look. It's going to run once for 7, correct? It's going to run once for 5, right? It's going to run once for 3, right? It's going to run one for 1, right? Is 1 still greater than or equal to 0? So it's got to run one more time. It's going to go for -1. Okay. I don't give a shit about what -1 is. All I care about is that it hits the terminating statement. Okay. So now when I add it, okay, so I have everything. Okay. If I were to, so I'm going to do my first call. Okay. I'm going to try excuse my annotations. Okay. I'm going to do the best I can. Okay. So my first call is 7. Okay. So what gets stored? 7 plus. Okay. And what's n minus 2? What's 7 minus 2, guys? Come on, you're AP students. 5. Apparently Thanos is too busy eating a sandwich. Okay. 5 plus. Okay, so then I run it with 5. What gets stored? 5 plus. Okay. What's 5 minus 2? Thanos?
3.
Thank you. Thanos' voice changed to eons. Very good. Okay, now we're going to do 3. And then what gets stored? 3 plus, the process gets stored. Then we're going to do 1 and the process gets stored. Then we get to -1. We're returning 30. Now, last in, first out. 30 plus 1 is 31. 31 plus 3 is 34. 34 plus 5 is 39. 39 plus 7 is 46. How many of you got 46? Okay. Clear my beautiful drawings. Okay. So again, it's last in, first out. So theoretically, this equation should be 30 plus 1 plus 3 plus 5 plus 7. 46. And not 46 factorial. That was just more like 46. Okay. So, all right. 30 plus 1 plus 3, because what's happening is it's actually working its way back out. Okay. Any questions on that? Okay. So last in, first out. Okay. So pre-recursion. Okay. So that's what LIFO is, pre-recursion. Okay. So now when you're dealing with numbers and it's just like this, this is easy. Okay. This is easy. All right. It's when you start printing things that crap gets real. Right, Right, Alex? Right? Right? Okay, whatever. I hate you. Okay. By the way, Alex, did you win your physics competition?
It's tomorrow.
How dare you correct me? Okay, now, okay, let's go. All right, so here we go. Pre-recursion LIFO, all right? Public static void, Homer, int n. Let's take a look at this, okay? Pre-recursion. So everything that we have been talking about is pre-recursion, okay? If n is less than or equal to 1, system out to print line n. Else, Homer, n divided by 2. System dot out dot print line, comma plus n. Okay, now that is still stored. Okay, now let's take a look at this. All right, so let's say that I put 9. Okay, all right, now let's say that I run 9. Okay, so what do we do? We're gonna do a couple of things. Okay, we do a couple of things. Okay, we have to go through and finish everything else. First, what is the terminating statement?
N is less than or equal to 1.
Bingo. Okay, perfect. Okay, now with print statements, there's not really a process. It's simply appending. You're just appending. Okay, so let's take a look. 9 goes in. Okay, what does it store? Comma 9. Okay, then, but it was, so we run this first, but we still have to store this. Okay, we still have to store this. Okay, that's Spanish for we have to store it. Okay, this is, okay, the next thing, okay, comma 4. Okay, then comma 2. Then we finally get to 1. What spits out? Last in, first out. So the last thing that first out, we spit out n, but we also have to regurgitate everything else that we were holding on to. Okay, so 1, comma 2, comma 4, comma 9. Your turn. And I don't know about you guys who've had computer science before, but I would say I teach recursion pretty damn well. This is a ruler. I should have been a professional rapper. Okay, what is the base case? Oh, now it's a party. Oh. What is the base case, Gary?
7, right?
Nope. What's the terminating statement?
Oh, less than 1 or less than or equal to 1.
N is less than or equal to 1. Base case, terminating statement, same thing. Okay, first of all, how many times is this going to run? Quattro tiempos, okay? We are going to be doing this quattro times. 7, 5, 3, and the uno. Is the uno less than or equal to 1? Yes, it is. So what is the first thing that gets stored, Lance?
The 1.
No.
Oh, you mean the set, like the 7 comma?
Yep. Then what gets stored?
5 comma,
And then?
3 comma.
Perfect. Okay, so what spits out? What spits out? Uma, you look a little too casual. Will, what spits out? This is a printing. We don't add these numbers together. It's just depending. What
So-
spits out?
It would be 7, comma,
Nope. LIFO. What's the last number that went in? Last in, first out. Uma, what would print out?
Wouldn't it be 1?
What prints out? Tell me everything that prints out.
1357.
Are you sure that's what prints out? Who agrees with her? You're wrong.
Oh,
Eubin, what prints out?
So it 1, 3, comma, 3, 5, comma, 5, 7, comma.
How, I can't believe I'm actually saying this, but Eubin is wrong. Okay, Dylan, our resident expert here. What prints out?
Would it be 1, 3, comma, 5, comma, 7? Comma?
Ah, dang it! Damn it! Good catch. Yes. Okay. 1, 3, comma, 5, comma, 7, comma. Okay. Darn it, Dylan. Yes, Gary.
Wait, why doesn't it start from 7 again?
Because what's happening is it's last in, first out. Now, had this print statement been before this, it would print out 7. It would be easy. It would be 7, comma, 5, comma, 3, comma, 1. But because it comes after it, it has to be stored and you can't spit it. So imagine like it's in a moving band. Let's say you have a moving band. Okay, the first number that goes in is 7, comma. So 7, comma gets put in the back of the the moving band. Then 5, comma, then 3, comma, and then 1. Now I've hit this base case. I'm not calling on the method anymore. I got to take all of this stuff out of the virtual memory of the machine. So I start with the first thing I put in, the 1, then the 3, comma, then the 5, comma, then the 7, comma.
Okay, so basically it runs like that method 1 and -2, right? And then it does that for all of the numbers and then it prints it out?
Yes, it stores because it still has to do that print statement. It's not a return. It still has to do something with it. But before it can do anything with it, you've already called on the method again. Key rule of thumb. In a question like this, this will always be the first end. Okay. Oh, easy. Oh, easy. Okay, so we're good here. Wow, this mouse really jumped ahead. Okay, so let's keep calm and kick it up a notch. See what I did there? Yes, Uma Thurman. Yes.
just real quick, why wasn't there a comma between 1 and 3 again?
Because here's the thing. What was being stored? So in the first one, 7, comma. Okay. So what spit back? So the first thing that got put into moving van was 7 with a comma after it. Okay. Note if I put comma 7, yeah, you'd be okay. But I put 7, comma, then 5, comma. If this would have been n plus comma, then it would have been 1, comma, 3, comma, 5, comma, 7, comma. Okay. But what happened is this stored. That's how you have to look at it, Uma. What is actually being stored? 7, comma. This was meant to throw you off, okay, in particular, because what a lot of people would have done how many of you just by default probably would have rushed and chose that as the answer? Be honest. Okay, those of you who are raising your hands or that are not, I can tell you right now, you're full of it. I know a few of you would, okay, all right. Yeah, I saw it happen on the last exam, okay? And there was about 8 people that got the question wrong with the comma at the end. So I know it was, you know, you guys have to slow down, okay? It's done on purpose. Some of the AP questions are going to get like this also. Okay, they're also going to be like this. Okay, all right, so now let's take a look at this one though. Multiple recursion calls. Okay, you will not, this is called two-level recursion. You will not see this on the AP. Okay, the most you would get is one-level recursion, but this is kind of just to show you how cray-cray, that's what the kids say on the street nowadays, okay, how cray-cray recursion can get, right, Lance? Okay, so public input is, how many possible base cases do we have? 5.
Isn't it just 2?
There's 2, exactly. What are the base cases? Will, when can this statement end? What are the 2 base cases that we have?
N equals 1 or n equals 0.
Bingo. Okay. Now, Eon, what's the process?
What do you mean by process?
Oh, come on.
I'm a bit confused here.
Thanos, what are we doing with the numbers?
We're adding them.
Thank you, Thanos. This is the process. In a recursive statement where there is no print statement, this could be divide, this could be multiply, this could be subtraction. This is called the process, Eon. Okay? Oh, I think I know what one of my quiz questions is going to be tomorrow. Okay, so now some of you probably thought this. 6 plus boo is 5 plus boo is 4. 5 plus boo is 4 plus b is 3. 4 plus b is 3, etc. So 0 plus 2 plus 3 plus 4 plus 5 plus 6 equals 20. This is what 75% of you would have done. When in fact the answer, whoops, oh crap, whoops. I'll go to that later. I meant for that slide to be later. Let me delete this slide. Okay, would be wrong. That was supposed to be more emphatic. Okay, I'll change it for the next class. All right. This is actually what is happening. 6. It's 5 factorial plus 4 factorial. We now have to run this method for 5, which would be 4 and then 3. But we also have to do it for 4, which would be 3 and 2. Then we also have to do it over here for 4, which would be 3 and 2. Okay, and for 3, which would be 2 and 1. Then we have to go here for 3 and 2 and run it here, and 2, 1, and 0. Now we have to do it for 2 over here. Okay. We don't have to do it. We don't have to do it for 1 or 0 because these are base case statements. Okay. And then 2, this 3 minus 1, we don't have to do it for 1. Then we have to do it for 2, which breaks down to 1 to 0. This breaks down to 1 to 0. Okay. So now all the 1s and 0s. Okay. So if you remember, okay, what is it? What was our statement? Okay. Otherwise return 0. Okay, so if it's a 1 or a 0, we're returning 0. So we have to now add all of these numbers up. But if it's a 1, it's a 0. So 0 plus 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 0 is equal to what? 0. Thank you. 2 plus 2 plus 2 plus 3 plus 2 plus 3 plus 2 plus 4 plus 3 plus 4 plus 5 plus 6. The answer is 38. Pretty crazy. Thank you. You know how long it took me to create this slide with Google Shapes or, or with the word art? I deserve some credit just for this damn slide. Okay, thank you. Thank you, Yubi. You're really sucking up today. Thank you. All right, so now, okay, this is 2-level recursion. You're not going to see this. I will not even put this on a test. And the reason why is even something like this, even for people that are quick at this, it could take you up to 4 minutes, 5 minutes. That's way too long for a multiple choice question. Okay, not fair to you guys, especially considering it's something you'll never see on the AP. But this is kind of just show you how crazy that recursion can get us. But imagine 3-level recursion. You know, so, okay, that being said, was that the end of it? Was that the end of it? So that, I guess, is the end of my recursion. preparation. Okay. Now your homework is already online. Okay. Coding Bat has a lot of good recursion problems in level 1. That is the most difficult that you're going to get. Okay. Your assignment is to do the Coding Bat problems, the first one, which is, I think, summation one or regular simple one, and then bunny ears, which were basically the first 2. Okay. You'll do them. Go ahead. I mean, you share with me anyway, so I'll see how many attempts it takes you to get it right. And then even if you don't get it right, I just want to see where your thinking is. Okay, try it 5 or 6 times. If you ultimately don't get it, that's okay. Copy what you have, make sure they're separated, copy both, put them in the submission box. They're due before midnight tonight, okay? I've also, because a lot of people, every year people request it, I've also included this PowerPoint. So this PowerPoint is online, okay, as well as attached to the assignment for download, okay? All right, good. I thought that was a good recursion lesson. Agreed? Okay, very good. All right, get the heck out of here, guys. I will see you tomorrow.